Hello students, in this video we will be discussing Cbse class 9 science NCERT textbook chapter 8 motion, the 11th part in the textbook. Okay, so we are going through the graphical representation of motion, and till now we've seen about distance time graph, and then we started with velocity time graph in part 10. So if you have any doubt in these topics, you can go through the previous videos till part 10. So today we'll just do a very quick recap of what we discussed in velocity time graph, okay, so that you will have a better understanding regarding what you learnt previously, okay. So we saw that for the graphical representation of motion, we were discussing about the concept of slope, okay, and for slope we saw that dt graph gave us the speed of the object, and for vt graph we got the acceleration, okay. And we also discussed a new thing called area, which is not there in dt graph, but for vt graph we got the area to give us the magnitude of displacement or the distance, okay. And I also told you we can calculate both displacement and distance from a single vt graph, okay. So it need not be necessarily speed, time for distance and all. With one graph itself we can do both. That we will see how we are going to do, okay. And we saw about a few cases under dt graph and vt graph. Dt graph we saw for stationary objects, and we were seeing about objects in uniform and non-uniform motion, okay, non-uniform motion. And for vt graph we didn't have this case, we had uniform motion, okay. And then for non-uniform motion means we had uniform acceleration, and today we'll see about in this video we'll be seeing about the rest of the cases. So first we'll do a quick recap of what we saw already. First one was uniform velocity. Well, uniform motion, uniform velocity is what? The velocity keeps remains the same throughout the motion of the object. Then you will have the graph to be a line parallel to the time axis, so where you can say the slope to be 0, okay. So there is no acceleration, that is why the velocity is going to remain the same. The next one is for an object starting from rest, and then it is moving with uniform acceleration. It is moving with what? Uniform acceleration. So that is what we are seeing here, okay. So there is a velocity here, time here. The velocity is going to be 0, that is it is starting from rest. So u will be 0 and you have a v here, okay. This is v and this is u, and our u is going to be 0, okay. And we know that the slope is nothing but the change in velocity by time taken, and the slope is giving the acceleration, and the area is giving us the magnitude of displacement or the distance. So area is this part under the graph, okay. So this is what we saw. The next one we discussed was about an object starting with an initial velocity. That means what? There is a u. The u is not equal to 0. That means u is not equal to 0, and then it is moving with what? Uniform acceleration. So even in this, slope will give us the acceleration, okay. The area will give us the distance covered by the object or the magnitude of displacement. Got it? So now we will just have some sample graphs to understand how the area gives us the distance. So you are given a velocity time graph here, okay. So you are given a velocity time graph here. So for this velocity time graph, what do we need to calculate? We need to calculate the area. You can see that it is asking about the area only here, okay. So what will be the area under the VT graph? Area of this rectangle and triangle, isn't it? So we have a rectangle here, okay, AB, DE, and this is a triangle here, okay. So this is the rectangle, okay, and that is the other one is the triangle here. So for the rectangle and for the triangle, So what will be the area here? Area, you will have the area of the triangle to be, rectangle to be AE into ED. Area of the rectangle is what? Length into breadth, and half into base into height. So half into CD into BD. So when you are going to calculate, you can calculate AE separately, ED separately, CD and BD. Okay. So when you substitute everything here, you know AE is equal to BD. AE and BD are the same. Okay. ED is 2 and CD is also 2. Okay. So now when you are substituting, we are just calculating along the units itself in order to show you that you are going to get the unit to be meter only. See, area, you have AE into ED. What is AE? 4 meter per second. What is ED? 2 seconds. So second and second will get cancelled. Yes. So left with what? 4 into 2, 8 meter. But see here, half into base into height. Base is what? CD. CD is what? 2 seconds. Height is what? BD. And your BD is 4 meter per second. Again your second and second will get cancelled. Yes. So a half into 2 into 4 meter only. So 2 and 2 will get cancelled. So you are left with 4 meter. So when you are adding it together, you are getting only 12 meter. So meter in itself says it is talking about the distance. So with this we can say that the area under the VT graph will give us the distance travelled by the object. Again, little more interpretation. What you can say? You can say the slope is 0 here, isn't it? For this area the slope is 0. Here the slope is what? Negative. Okay. So that is what we are going to see next. Okay. So here we saw about negative slope, right? So that's what we are going to see here. Negative slope is what? Uniform retardation. Here we are talking about uniform retardation. So for acceleration, how did we have the slope? For acceleration, we had the slope to be increasing. The slope was increasing. Here for retardation, the slope is decreasing. That is, it is a negative slope. But still, it will give us the acceleration. Acceleration in terms of negative acceleration. In terms of negative acceleration. Because the slope will be what? Minus of V minus U. So what I get, you will get it in the negative only. Okay. So that you will do, and then you will be able to get the value of the slope for uniform retardation. What will be the area? Again, the same triangle only you will get. Okay. Now, what is the acceleration? So previously we saw about the area under this. Okay. Now, what is the acceleration between 2 and 4 seconds is what they have asked. 2 seconds is here, 4 seconds is here. Why not between 0 and 2 is because 0 and 2 there is uniform velocity. So the acceleration itself is going to be 0 because the slope is 0. Here the slope is negative. Slope is negative means what? You are going to calculate minus of rise by run. If you have any doubt in this, I think it's there in part 7. Please go through it. Okay. So rise is what? Your BD and run is what? CD. Okay. So when you are going to calculate that, you are going to get it as minus 2 meter per second square. And as I have told previously when you did some numericals, when you are writing the acceleration, it will be in minus. But when you are writing it retardation, you are going to mention it only as plus 2 meter per second square. Okay, hope you understood this. This is for negative acceleration or retardation. Okay. Now, non-uniform acceleration. Non-uniform acceleration only, even retardation will also come. Okay. So, here again it is similar to what your speeding up and slowing down, what we saw in the distance time graph. Okay. Here also increasing acceleration and decreasing acceleration. Okay. So your acceleration is going to be non-uniform. Okay. So slope is what? Increasing. Okay. This is similar to what? Speeding up. Okay. Again, if you are going to calculate the area under the curve, it is going to be this area. Okay. So this will be the area under the curve. So when you are going to calculate that, you will be able to calculate the distance covered by the object. So likewise, decreasing acceleration. Again, the slope will give us the acceleration, the area will give us the distance. Okay. So these are the various cases of velocity time graph. Okay, now these are the few points to remember, so that you will I've just put everything down into a single concept. Okay, see here, speed will give us what? The slope of the dt graph, and acceleration, slope of the vt graph. So in the question, if you are asked to find the speed, okay, you have to check if it is going to be a dt graph. Okay, if it is a dt graph, you can calculate from the slope. They ask you the acceleration, they would have given you a vt graph. So again, from the slope you can calculate. If they ask you to find the distance, you are going to find out the area under the vt graph. So this is how you are going to calculate the various parameters by looking at the graphical representation of motion. Okay, and whenever you have a graph with a straight line parallel to the time axis, then the slope is 0 accordingly for your dt and vt graph. Okay, what is this slope all about? Vertical change by horizontal change, or you can say it as change in the y coordinate by change in the x coordinate, which is nothing but your rise by run. Is it clear? Now I told you we can calculate the value of distance and the displacement from a single vt graph. Okay, so how do you do that? So for example, if this is a vt graph, so you saw a vt graph like this. Okay, sometimes the graph may also go down like this. That means you have something below. This is what? Line 0, right? So whatever you have below, for this what you will do is you will calculate the distance. So how? You will have an area here also, isn't it? Here you have an area. Okay, here you have a rectangle with area. So let me take this as A1, this as A2, and this as A3. Okay, when you are calculating the distance, you will do A1 plus A2 plus A3. But if you want to calculate the displacement, whatever is below the time axis, you will subtract. So you will have A1 plus A2 minus A3. Got it? So this is what, this is how you will find out both the distance and the displacement from a single VT graph. Is it clear, children? So we will be seeing some numericals also supporting these concepts. Okay. So if the VT graph goes towards the negative, that is the negative part of the x-axis. Okay, then the value of that area should be subtracted to find out the displacement of the object. Are you able to understand? Yes. So this is how you will find out the distance and the displacement from your single VT graph. Okay. So with this we are completing the 11th part of the chapter motion. Okay, so in the next one we will be doing some numericals related to the VT graph. Okay, VT graph, DT graph and all. We will be doing it one by one so that you can understand clearly and do it. Okay, so please remember the points to remember which we discussed. These are very, very important. Okay, so if you remember these concepts itself, solving any question related to graph is going to be easy. So I have seen many children struggle when it comes to numericals related to graph, but it is actually way more easier. Okay, so even you have some graph related questions in your NCERT exercise also. So I will solve that also for you in the upcoming videos. Okay, see you again in another video. Thank you, children.